Right, short date and learn objective, please. Okay, to identify parallel lines on straight line graphs. Pause the video while you're doing that and then press play. Right, okay, so I think the first part of those from that other video is fairly straightforward. So if we go back to our original equation, y is equal to mx plus c, and it's just remembering that this m here, that is the gradient, isn't it? It's the gradient. So anything where this is the same, where m is the same, you've got this is a parallel line, isn't it? Okay, so we know that if this was 2x plus 11, and then this was y is 2x minus 34, these would be parallel. They would be parallel because the gradient is the same. The gradient is the same, so they'll always be the same distance apart. And remember, the c it just represents where it's going to cross the y-axis, isn't it? It's the y-intercept. So this is where it would cross the y-axis up on 11, and this one would be way down on 37. But they are still parallel because this value is the same, isn't it? M is the same. So that's the key. So whenever you're trying to find pairs, if you're asked to find which ones are parallel with each other, so if you've got y is equal to 3x plus 4, you might, anything with a 3x is parallel. And just remember, you could have something like minus 3 plus 3x in a different place. So all these three lines would be parallel. If there's nothing there, it's just going through, that's going through the origin, isn't it? Okay, so it's nothing on the y. So remember, these can be swapped around. So if you do see it like that, just swap it around to 3x minus as opposed to 3x minus 3, and that's the same there, isn't it? Okay, so that will be so all these three are parallel. Okay, so it's just looking at your m, isn't it? Your m factor. Okay, right. So if you were to be asked, and you will be very shortly, okay, to write down an equation parallel to this equation, y equals 5x minus 1, and you just write down an equation which is parallel to that. You can write, as long as you got y equals 5x, you can put anything here. Yeah, plus 999. Okay, it's probably unnecessary to do that, just keep it simple. But as long as you keep those the same, as long as you keep the m the same in the y equals mx plus c the same, the gradient will be the same, so therefore it will be parallel. Nice and quickly have a go through these, please. Okay, so you write an equation of write the equation of a parallel line to each of these following. So write an equation which is parallel to that, an equation is parallel to that, an equation is parallel to that. Okay, pause the video while you do that. Shouldn't take you too long, and then we'll move on with the lesson. Right, okay, so on question 1, as long as your y equals 2x, anything can be there. Y equals minus 3x, again, anything there. You can leave it blank, or you can have a plus 9, whatever. And on this one, y is equal to 10x, and you just need something here, so you need a positive or a negative. So as long as these show the gradients, nice and straightforward, those. Okay. Then the other questions you'll be asked to do, okay, with these, is to write down the equation for a line that is parallel to this. So this is my line, okay, this is my line, y equals, and I need to do a line parallel to this, but it's passing through 0, minus 3, 0, minus 3. And again, this one is quite straightforward, because if we go back to 0, minus 3, okay, this is x, so x is 0, and then on the, so remember, you go across the corridor and up the stairs, so across the x, across on the x-axis and up on the y, isn't it? Okay, and that's the key with these ones. So we know it's x 0 on the x-axis is going to be right there, isn't it? And then minus 3 will be somewhere down on here. Okay, so actually this is all we have to do for this one, this is just the y-intercept. Okay, so if I wanted to do this one, all it would be is y equals 5x minus 3. Okay, 5x minus 3, because this is the, remember on our formula, y equals mx plus c. C is the y-intercept. So we're just changing the y-intercept there because x is 0. When x is not 0, it gets trickier again. Okay, let's have a little look, one more of those before you just do it for yourselves. Okay, so let's change that to 3x plus 7, and then this is on 0, 5. And again, you'll notice because the coordinates there is 0, it's 0 on the x, isn't it? So that does make it very much easier for us. So again, y is equal to mx plus c. So we know that if it's going to, y is equal to, we know if it's going to be parallel, it has to be 3x. So we just have to change this, because this is, and this tells us that the y-intercept, because this is 0 on the x, okay, 0 on the x axis and 5 on the y axis, tells me that would be plus 5. Okay, and this could be a minus as well. Okay, so all you do there is changing where the y-intercept is. Okay, changing where the y-intercept is. Right, have a little go at those. Have a little go. Have a go at these two, please. Okay. Okay, pause the video while you do them, and off you go, and then press play when you're done, please. So let's have a little look. Okay, so we've got y is equal to 3x plus 5, and the coordinates we're changing it to, the next one, is 0, 2. The 0 here tells us that that is 0 on the x-axis, so 2 on the y-axis will exactly give us the y-intercept. So all I have to do, we're going to obviously keep the gradient the same, but instead of going through the 5 on the y-axis, it's going to go through 2. So it would just be that. Okay. Let's have a little look on the next one. Y equals 4x minus 1. Okay, and with our new line, okay, it's going to have the same gradient. Okay, but it's going to have a different y-intercept. The y-intercept here is across the corridor to 0 and up to minus 3, so you're just changing it to minus 3, and that's when our first value that is 0. Okay, it gets trickier when it's not 0. Okay, right, okay, good. Let's move on to the last part. Okay, and these are definitely the trickiest ones. Okay, a bit awkward these. So write down the equation for the line that is parallel to this line. So this again is my parallel line. So I've got y equals mx plus c, and this is my parallel line. Okay, y equals 5x plus 4, and I got to find a line parallel to this which goes through, in this case, 2, 9. Okay, it goes through 2, 9. So that's 2 on the x-axis and y on the 9 axis. Now rather than draw it, and we could of course draw the line and we could go across 2 and up to 9, we're going to try and calculate that without doing that. Okay, now again we know that the only value that's going to change is this 4, is the c, so we have to find the value for that. Okay, so what I'm going to do on here, because I know for this one 4 is my answer, so I'm just going to turn that into a c. Okay, so that is the value we have to find. We have to find c, don't we? Okay, now what we do, we now substitute our values here, because x is with 2, because it was across the corridor and up the stairs. I'm going to swap that 2, so 5x becomes 5 times x becomes 5 times 2, so this becomes 10. So we get 10 plus c, and the y is swapped to a 9. So now we left here with our equation. Okay, we need to find the value of c. We'll just carry on with the method I've taught you before. So we want to get, we'll just have c on this side, so we're going to take away 10 here. So the balance method, so we take away 10 there. That leaves us with c. 9 take away 10, minus 1. Okay, minus 1. So the value of c, when you have these coordinates, is minus 1. So we write out again. So we know that the 5x is going to be the same because it's the same gradient, so it's parallel. And then the c is now minus 1. So that would be our answer. Okay, yes. Okay, they're quite tricky. They're quite tricky. Let's have a go at another one. Let's just change it to, let's have a look. Y is equal to 2x plus 10. Oh no, wrong one. Sorry. Y is equal to 3x plus 2, and this time it's going to pass through 415. Okay, so this is our original. And again, I'm just going to write the equation, x plus c. So I know that my new line, this is my line, and I've got to find a parallel equation passing through this. So I know, again, first of all, I know that y is going to equal 3x. That's the gradients are going to be the same, aren't they? But this c is what I need to find out. I need to find out this c. Okay, it can't be plus 2. So this is what I'm going to kind of just call that c. Okay. So again, these are the coordinates I'm using, 4 and 15. I'm going across the corridor, so x is equal to 4 and y is equal to 15. Okay. So now I'm going to swap them over. So 3x, 3 times 4 is 12. 15 goes here. And I've still got my plus c. Again, I'm going to use my balance method. I only want to be left with c on this side of the equation, so I'm going to minus 12, minus 12. 15 minus 12 is 3. So c is equal to 3. So in my so I go back to here, c is equal to 3. So it becomes y is equal to 3x plus 3. Okay. C is equal to 3. They're quite tricky, those ones. Okay, watch the video again, and not just my video, but watch the other video on the Corbett Maths video, because that's so really, I think it's quite a good way of explaining it. Okay, so obviously we've watched the 2 videos on it. Have a go, please, at these questions. Now I'll try to find them. Hang on, there we are. So, actually, first of all, sorry, let's slow down there. Could you have a go at these first, please? Have a go at these first, sorry. Have a go at those questions, 6, question 7. Pause the video while you're doing that. We will go over them. Okay, we will go over them. Right, let's have a little look. Now you've completed these. So let's have a look. The original one is y equals 2x plus 1. Now I know that obviously I'm going to change this. I'm going to change where it's passing through the y-intercept. Okay, so this becomes a c, and it's the c I need to find. Okay, right, and my coordinates here are 1 and 8. 1 and 8, so that's going to be x, and that's going to be y, isn't it? X along the x-axis, along the y-axis. So 2 times 1 is 2. So y equals 8. So therefore I'm going to take away 2 there, do the same there, 6. C is equal to 6. So my answer is y is equal to 2x plus 6. Okay, plus 6. Let's have a look at the second one. Let's have a little look at the second one. Okay. So here we've got y is equal to 3x plus 2, and then we're going to find a parallel line to it, but going through the 1, 1. Okay, going through the 1, 1. So all we have to do is again, so this is going to have to change, isn't it? Okay, where it's going through the y-intercept is going to change. Everything else stays the same. So that's going to be our C. So again, our coordinates 1, 1. So that means it's nice and easy. So there's 1 on each side. So there's 3 times 1 is 3. 1 times 1 is 1. Okay. Plus. So again, I want to be left with just C on this side. So I'm going to take away 3 there and take away 3. Okay, that does leave me with C. 1 take away 3 minus 2. So C is minus 2 in this case. So our parallel equation will be y equals 3x minus 2. Okay. Don't worry too much if you're struggling with this last part. Okay, it is tricky. It is tricky, but just have a go at them, and you might find that you might find you're better at them than you think. So can we please have a go at these questions? So just page 233, questions 3 to 8. The last couple here are quite tricky, but you should be able to do up to 6. Okay, and then if you do manage to do those, there's the extension questions below. Okay, good luck with that, everyone. Bye.